You may have noticed that RP is an asymmetric complexity class just like NP, meaning that words that are in the language and words that are not in the language are somewhat treated differently. And so just like for NP, we have a complement class for RP, and this complement class is called CoRP. It contains all the languages whose complement is contained in RP. Of course, we can also define CoRP directly without any reference to RP. We just write down exactly the same thing that we wrote down for RP, and then we switch the conditions for inputs that are in the language and inputs that are not in the language. So if a word is in the language, then we say that our Turing machine has to accept for sure with probability 1. And if the word is not in the language, we say that our Turing machine has to reject with a probability of least 1/2. And for RP, we said that we might get false negatives, but we will never get false positives. So for CoRP, it's just the other way around. So you might get false positives, but you will never get a false negative. So if the answer is no, then you can be sure that no is really the correct answer. But if the machine returns the answer yes, then this might not always be correct. Again, we should think about what the relationship between this class CoRP is to other classes we know. And we can use the same reasoning we did for RP to establish that P is contained in CoRP. Simply don't use the random bits. And CoRP has to be contained in CoNP. Exactly the same reasoning as for RP being contained in NP. An interesting question is, what is the relationship between RP and CoRP? And this is not exactly known. So we do not know whether RP is equal to CoRP or not, just in the same way that we don't know if NP is equal to CoNP, I suppose. So there's some uncertainty there. Some people might think RP is equal to CoRP, other people might think it's not equal. We just don't know yet.